Okay, we'll have a look at July 2012, question 2 from the navigation paper. We're told that our vessel referred to in question 1 anchors in this exact position here with a maximum draft of 9.8 metres at 0100 hours the 24th of April. The vessel is to weigh anchor at 1500 on the 24th of April. The first question asks us to predict the underkeel clearance when the vessel anchors. So the first thing you have to do is plot this exact position on the chart, and on that position you will see on the chart that there's written 11.3. Now that means that when there's no tide at all, there is 11.3 metres of water. Okay, so we've already got 11.3 metres of water. To find our underkeel clearance when the vessel anchors, what we have to do is calculate the height of tide at the time of anchoring. So at 0100 on the 24th of April, we have to add to this 11.3 metres our height of tide. And once we've got that total value there, we can then subtract our draft, maximum draft of 9.8, and that will give us the underkeel clearance when the vessel anchors. So let's have a look at that first. So we have to find the height at 0100 on the 24th of April. First thing we have to do is establish if Ballycotton Bay 754 in the tables is a standard or a secondary port. So we go into the tables and look under 754 and we find that Ballycotton is a secondary port. So what we have to do is find the standard port for Ballycotton, and we find that it's Cobh, Ringaskiddy, 751. So we go to page 26, and on page 26 we will have to have a look. So here's page 26, that's Cobh, and we have to pick from there the times, the relevant times for the 0100 on the 24th of April. So we go to the 24th of April and we see that 0230 we have 3.6. Now from this we'll have to use the day before. So at 2029 we had a low water on the 23rd of 1 metre. Then on the 24th at 0230 it was 3.6. Now we anchored at 0100 hours, so we will have to use these two, although one's on the 23rd, one's on the 24th, they're the ones that we would use, 2029, 0230, and we'd have to convert those from standard to secondary to use our tidal graph. So part A, predicted underkeel clearance when it anchors, we use low water on the 23rd and high water 0230 on the 24th. So what we have to do now, we'll have to look at converting the times and the heights. So if we look at the height calculations first, we've written down 3.6 of 1.0. First of all, we get our seasonal correction for the standard port of Cobh, and we would get it along the bottom, these seasonal corrections, and you must remember, whatever value you get, you must change the sign because it's the standard port. Now, in the tables we found it was minus 0.1, so we changed that to plus 0.1 and we apply those values there. Now we need to get our main correction. So just to recap, for the main corrections you get mean height, we'll do high water first, high water springs and neaps 4.2 and 3.3 for Cobh, and then for our Ballycotton we see actually straight away that there's no height difference, 0, 0, 0, 0. So I've written those down here 0, 0, and because it's 0, 0 obviously there's no correction. So for the standard, the main correction for the standard port is 0. Then we get the low water values, mean low water neaps and springs 1.4 and 0.5, and for Ballycotton we have its minus 0.1 and 0. So we write those values down. So for low water we write down 1.4 and 0.5, minus 1 and 0.0. Now our height is 1.1, so it falls between 1.4 and 0.5, so our correction must be slightly less than minus 0.1 because we're going down from 1.4 towards 0.5. So we do our usual interpolation, 1.4 to 1.1 is 0.3, 1.4 to 0.5 is 0.9, so 0.3 over 0.5 either multiplied by 0.1 or equals x over 0.1, whichever way you want to do it. The value comes at 0.03, so we're going from 0.1 minus 0.03, and our low water correction is 0.07, which we've written there. Then lastly we apply our seasonal correction for Ballycotton. The sign doesn't change, So we have values of 3.6 and 0.93, and they're the two values that we will use for the Ballycotton predictions on our graph. Now we need to calculate the time of high water, of course, for Ballycotton, because we need to write that on our graph. Again, from the top of the tables for Cope for height differences for high water, 5, 11, 17, 23, and for Ballycotton -11 and +1 minute. So we write those values down there, and we're going to high water's 0230. That was the value we originally took from the daily page. 2300 to 0500 is when that occurs. So 2300 to 0500 is on the bottom to calculate our percentage, and 23 to 0230 is on the top. The difference between -11 minutes and +1, which are the two Ballycotton corrections, those two together combine to make 12 minutes. So we're finding a proportion of that 12 minutes to apply. So 23 to 0230 is 3 hours 30, which is 210 minutes. 23 to 0500 is 6 hours, which is 360 minutes. So 210 over 360 times 12 gives us 7 minutes. We're going from 23 to 05, so we apply the 7 minutes from +0.1 towards -11. So that means our correction is actually -6. So we apply it to the 0230 and -6, and we find the high water at Ballycotton in 0224 hours. So we would go to our graph, and we would write the 0224 in here, and we'd put our low water and high water values on and draw the tide line. We know that 0224 is the time for high water. The time we want is an hour, 0100. Therefore, it's -1 hour 24 from the 0224. So we go back 1 hour 10, 20 to 24 and draw a vertical line straight up, because that indicates the 0100 time. Draw the line straight up to the top of where it hits the curve. That's a vertical line straight up, then a horizontal line straight across to where it hits our tide line. Go up or down, whichever way, it's the same value, and we find that we have a value of 3.3 height of tide. So that means at 0100 hours, when we anchored, there was a height of tide of 3.3 metres. So as we touched on earlier, we would add that to our charted depth of 11.3. So when we anchored, there was 14.6 metres of water. Our draft was 9.8, so the underkeel clearance is 4.8, one subtracted from the other. So that's how we would solve part 2A. B and C are of course connected. We need the predicted minimum underkeel clearance whilst the vessel is at anchor, and the predicted time that this occurs. Well, if we go into the tables, go back to Cove in the tables for April, and we will see on the 24th of April, we went from 2029 to 0230, so we anchored at 1 o'clock. We're going to leave at 1500. Now at 1500 is high water, so we can see from the tables that at the low water time, 0908, 0.9, that must be the time and the height of low water. Obviously they're for Cobb, so what we have to do is convert those to Ballycotton, and they will be the times and heights when it occurs, and therefore they are the answers to B and C for the problem. So if we have a look here, we've written down Cobb, it was 0.9. We do the usual things, the corrections for low water, and we find that our low water height is 0.84. We did the same as we just talked about solving the previous problem. We've applied the seasonal corrections and the main corrections. We found it was 0.84. We add that to the charted depth. That gives us the depth of water that's actually there at low water at Ballycotton. Subtract our draft, so our minimum underkeel clearance is 2.34 metres. And that's the working out there to get the main correction. Of course, the time needs to be changed, of course, 0908. So same as before, work out a proportion of the difference in time, and we find that the correction to apply is 5 minutes. Low water Cobb is 0908. Apply the 5 minutes, so our time of the underkeel clearance for Ballycotton is 0903. So that part B and C, once you've established from the daily page the time and height of low water, once they're converted for Ballycotton, they must be the time and height for the answer. And that's how you would solve that particular problem.